Was today the day for obscure sci-fi references?
It's really good for which part? Oh, Ansible.
Between Ansible and Sidel.
Exactly. I didn't get that reference until I was talking to someone. I'm like, yeah, we're using Ansible. Like, really?
Yeah, when I first started, I said I had to learn about, I had to find out about this. So. Did they take anything from?
I think so. I haven't actually looked it up yet.
It's a series. Just a movie.
I remember. But yeah, no, it's from that thing.
Yeah, yeah.
Nice delay there.
That was a huge delay.
How long is it?
Like 20. One, two, three.
Your camera's slow.
Wow, it's way behind.
Yeah. It's like
Still
2
hasn't gotten
minutes.
your woe really yet.
Oh, really?
I like your shirt, Gordon. Thanks. And then my glasses. I'm here because you broke something.
That's funny.
Oh, you think about Jimmy Fallon? The SNL skits? ITV?
Oh no, actually, what's his move?
Move!
Has anybody know that Silicon Valley got like go off the air with some cancer?
I don't think so.
That's a good show. I hope not.
Yeah, well, but my wife liked it. She was watching it. She didn't really get it, so I just wondered what that actual mass market video is.
I've not heard of it.
The HBO show, they're following a startup in Silicon Valley. It's quite funny. I enjoy it.
We were on a road trip and I was listening to some podcasts, you know, and I'm like, I'm sorry, I got this. So she's like, that's how they talk on Silicon Valley.
I told her, I said, this is like it's real.
It's literally, I know like every single person in that.
Like everything they say is actually real. Sometimes they take it more than
I love like the really difficult like wording they try to use. Oh, he's using a hash. I'm like, oh, really? That you can do.
It's not like anybody's going to know what a hash is anyway.
Yeah, most people, yeah.
Yeah.
Or associate hash, or whatever exactly what they said.
Dude, Hash Table, was that what? It was something.
It's a good show. It's great.
So look at hashtag.
Oh god.
No, there's the one guy they hired, like the guy, the consultant that came in, like, oh, he hacked B of A. Turns out, like, when he was there, he freaked out. He was like a consultant for B of A. He just broke everything. He signed the silence clause. The best is the logo design.
Dude, the garage.
Oh, yeah, that was good. That was good.
I know the logo you really want is two P's again.
Lowercase. What do you think? Did we just start it?
Let's give people a few more minutes. First time being here, might not be able to find it.
I'm running around this huge complex.
Were they? And you can easily drive by it if you're not taking pictures.
Yeah.
Did they say they put you on the schedule, like bring us like 2 minutes? Or is it not?
I think I still need to talk to someone, but yeah, it sounds like it shouldn't be a problem.
Well, hey, as a backup, you know, if they've got a schedule conflict, we can always go to Wolves. Have you been to the new location yet?
I have not.
Yeah, it's much bigger and nicer. Oh, right next to IKEA.
That's even fun.
And now we have an 84-inch Ultra HD.
Sold.
And is that
But you got
smaller or bigger than
stadium
4K? Is that smaller than 4K?
No. 84-inch diagonal,
Right.
4K.
Oh, it is Ultra HD 4K?
Yeah.
Oh, okay.
Ultra HD 4K.
They've got so many buzzwords for different.
Yeah, I think we're gonna settle on 4K.
What does that panel run like? 8 to 15,000?
Yep. Exactly.
You get that $300
Oh,
31-inch on Amazon.
It's expensive.
I want to say it's like $300-$400
Wow. For what?
for like a 31-inch 4K display on
I
Amazon.
heard like Asus got one or something. I haven't even looked into it.
Roasted a whole 7 frames per second.
It's what?
I know,
A
right?
whole 7 frames per second.
Oh, God. Look. TVs. Yeah, it's the, oh, yeah.
Oh, is that it? Yeah. $4.99.
Yeah, there's one of those that's not a true 4K though. It just accepts 4K.
This might be it.
So that's a 30, 840 or 20.
Oh, it does say it's 30, 40 by 21.
And I've seen some of them that don't have the input or something. Something weird about it.
Well, it's 4K by 2K, they're just rounding up and down to a 30 and 40. But it only goes at 30 hertz. So that's not very fast. So, if you're watching video on that, it's not going to look very good. But, you know, for this type of stuff, it's fine. That's a wasting thing with all this cheap stuff.
It's kind of like when you're watching someone's screen on Skype and they start to scroll and everything goes
Right.
blurry.
Well, it's just if you're, you know, if you're watching like CNN, but as soon as you're watching like a movie or something where it's changing rapidly, it goes to crap.
The 85 inch, is that 120 or what is it? 240?
It's yeah, it's 240. But I think, you know, I mean, you got to be careful with all that stuff because some of them are panel resolution. You know, you've got 3 elements you really have to know that what it's actually converting everything to. Because some of them will accept all kinds of inputs and then they'll just convert everything to one standard resolution. And then they'll only update the data that the panel gets at every 60 cycles. Even though the panel refreshes at 120, so it's just refreshing the same data twice. And then you have, you know, so I mean, you have so many variables. It's not that. It's really expensive to get something that can truly, you know, doesn't just convert everything to the standard resolution, if that makes sense, the native resolution, by going through cheap, you know, D to D converters, I should say, and then, you know, having it go and stay at 120 hertz. The data refreshes at 120 hertz, and then the panel refreshes.
I'm glad you're
All
here
those
so you can
TVs
correct all my references to that.
They're all really expensive.
All right.
They're rare.
Yeah, I saw a Panasonic BT
Yep.
65. So
Those are awesome.
yeah, I wanted the ZT. I just couldn't quite justify myself from buying it.
Yeah,
But it's a great TV.
they're awesome. The only TV that was ever better was the Pioneer Kuro. But
And they bought their technology.
they did, but they never quite got there. Never quite got there. We had a Kuro in for service that was like 6 years old. Put it up next to the ZT. Kuro still looked better.
Really?
Yeah.
That's awesome.
But that's 6-year-old TV, so. But they were expensive, you know. They were 15 grand. You know, so they should look good. They should look good.
Market for TVs that expensive anymore.
Yeah,
Probably.
yeah, we sell them all the time. 15? We sell 15,000 on TVs all the time.
Staying after.
Close enough. $2,200. In between.
All right, so I tried to throw together, since when we were having beer last month, a lot of people didn't know what config management was at all. So I tried to throw together a quick couple slides on the comparisons between SaltStack, Ansible, Chef, and Puppet, and then gave homage to CF Engine for one slide. Some brief comparisons between the 4 different ones that I got from a really cool PDF ebook online where they went through and built the exact same sites on 2 different web servers in each of the 4 different ones. That way you can actually look, because I was always comparing, well, this is a WordPress config for Chef, and this was a Drupal config for Puppet, and this is a SaltStack config just doing remote execution. You're trying to compare how all the 4 different ones. So this will kind of show you, at least at a very high level, the 4 different types and how they work. And then I'll dive into what I've been doing with Ansible and how Ansible works at a very practical level, and then any questions. And then they use Puppet, and he uses Chef, so they can correct what I did wrong, which is most like. This is a quote that I got and kind of how I felt after going through all of the 4 different tools from that book, and kind of led me toward Ansible. If you can't figure out Ansible, then you probably should stop at Ansible and just go with that. So infrastructure as code, what do we want to move from and to? This kind of DevOps config management side. We want to move from logging into each server individually, running all the commands you did, remembering which commands you did, and then logging into the next server and doing the exact same thing over and over. So we want to move from this to make me a web server, and ideally make me a web server just like the one I just had, so it's all the same. So config management. Maybe it's not that beautiful, but that's kind of how it was to me when I first figured it out. And then you figure out the problems with config management, and you're like, oh shit, I should have stayed where it was. So the different options we have. So SaltStack and Ansible fall under a category called config and execution. Puppet, Chef, and CF Engine are under config management just by themselves. CF Engine is kind of where everything started. And then you've got good old Bash. You can always write, ooh, that's when PowerPoint crashed and didn't save the slide. So CF Engine, 1993. Puppet, I believe, was 2005. Chef was 2009. SaltStack and Ansible were 2009 to 2012, somewhere in there. And yeah, so CF Engine's kind of where it all started. They still have a product. I actually Googled that, apparently, and it's updated. They were in the news lately. Apparently they hired somebody else. But that's kind of where the config management sector came from. They were the first widely deployed, I guess. So Chef and Puppet will manage your configs and states of servers really well. SaltStack and Ansible do the same thing, but also have a component that bakes in execution. So you can easily run, if you're familiar with Tentacle, Puppet has some tools, Chef has some tools on the side, but this is built in from the core, all about running, executing commands on remote servers and reporting back. So let's build a LAMP server. This is kind of what I was using before. Actually, let me show you actual scripts. That's why I have these. So when I started in Vagrant, that's where we started realizing that writing an individual or logging into a server and building it from scratch just wasn't going to work anymore. So we built a bootstrap file. That's the first thing I learned in Vagrant. And so you end up with a file, and it works, and you can rerun it, and it's fine. But that's when you start realizing, well, what's the next step? So let's start with Puppet. So another slide that didn't save. Puppet has a master, and then you have slaves below it. These are the terminologies that Puppet uses. We'll hit directives and scripts that are called resources and manifests, and that's what we'll actually be writing. So first we need to go and log into all of the different nodes that we have, install Puppet. If this is assuming we've already spun up our master and our 2 slave or children servers, child servers. We need to set up the clients on each of the nodes and then tell it to actually run when it restarts so it can connect back to the Puppet master. We need to log in on each of those child nodes and actually add the key for it to talk to the master server. And then when it connects, it'll actually, when we run this command, it'll actually connect back to the master server. Oh, sorry, one thing. Master.dev is in the host file, or whatever IP address you're using for your master. So we're setting up 2 different servers. One is called Kitty, one is called Puppy, and then there's a master server. So once it connects back, we run this command. It'll connect back on both of the clients to the master server. Once we're on the master server, we're going to install Puppet Master, which actually manages all of your Puppet instances. We're going to edit the Puppet config, add the settings that tell it which server it is, and give it the key that it's going to use, and then start up Puppet Master. We're going to list out all of the certs. So Puppet cert list will actually list out all the certs of all the children that have connected, and they just sit there in a pending status until you actually approve them. Sign all the certs, because -y is good. And then we're going to actually write our Puppet manifest. So the Puppet manifest we're going to write, or we're going to write a template file, and then we're going to write an actual config file. So this is the template file we're going to write out. The actual HTML file is going to be displayed on our puppy or kitty server. If you can see there at hostname, that's the variable we're sending in. And the actual Puppet file that's telling us we want to install Nginx, we want to have 2 different files on it, depending on the server, and we want to have a user. So if you see at the top, package Nginx, ensure that it's installed. Then we have ensure that it's running. Make sure that this file exists and use this template. If you're the hostname puppy, then run this stuff. So we're going to copy down a puppy.jpg file and display it. If you're a hostname kitty, you're going to do the same thing, but you're going to use a kitty user, a kitty group, and a kitty.jpg file. So the directive language is kind of a custom DSL. The execution order is also custom. That's where you end up with the ensure statements. So as you're writing the file, you can't guarantee that it's going from the top of the file to the bottom of the file. So if you need something to run before another thing, you want to make sure that you're writing ensure statements that this requires this, or sorry, require statements. Require statements? Ensure statements. We'll call them ensure statements. Just use it. And that'll tell Puppet when it puts everything together and says, okay, I need to run this first, so make sure that we have the user before we create the file and show them the file, and make sure we do this before we do this. Remote execution, not bundled in at all. Puppet Labs has an open source project called mCollective, which I believe is similar to Tentacle, if you've used that before, to run remote execution on servers. Okay, so Chef layout. So the Chef layout is interesting. You have to have, this is open source Chef, not the hosted version of Chef. You have to create a master, and then you have children servers underneath the master, just like in Puppet. But you don't actually run the commands on the master. You run them on a workstation computer that connects to the master. Is that as far as, feel free to just yell if I'm doing this wrong.
That's right.
So terminology, directives are the resources, directive scripts are recipes, similar to Puppet's manifests. And then the cookbook is the group of recipes for the group of servers. So first we're going to install Chef on the master. Pretty straightforward. Installing Chef on the workstation. So each kitty and the Puppet servers we need to install, or sorry, this is the workstation. So this is what connects to your master. So we have to install Chef on that. We have to install, make sure we have Ruby in the path. We have to get Git and actually pull down the Chef repo. Straightforward. Then we actually run the config to actually set up Chef. It's a little bit more intensive, but that's all you need to do to actually get the master going. So the overall process is easier than Puppet. It has kind of a walkthrough similar to MySQL does when you install it. Installing Chef on the children. We use a tool called Knife, which is what Chef uses to actually run things on those remote servers, so installations. We're going to puppy.dev and kitty.dev are our Etsy host files, so those are IP addresses. And we're running Bootstrap to actually install what we need for Chef to connect back to the master. We're going to create a cookbook, Knife create cookbook, or Knife cookbook create. And then we're going to modify the files in the cookbook. Did I miss any steps? Okay. I was expecting to. So similar to Puppet, same HTML file we're trying to do, different variable syntax. And then our actual config file. So apt package is a module. Make sure that we have Nginx installed. Make sure we have it enabled and it's started. Use this template file. So instead of saying copy this file and use this template, we're saying use this template file and put it here. Here's the source file. Put it there and give it the action of create as opposed to delete. If the host name equals puppy, then we're going to do the same thing as we were doing before. Use this cookbook file, so that's a file that's actually saved next to your config files. Deploy it on the server, owner group just like before. Make sure we have the user, and make sure that the file is owned by the user. And then the same thing for Kitty. So to actually run this on the remote server, now that we have the cookbook written, we're on our workstation computer. We write knife cookbook upload. That will upload all those files to that master server. And then we say knife node. We run this command. And we say the name of our cookbook is taste. So run taste on puppy and run taste on kitty. Or, sorry, associate puppy and kitty to those cookbooks. And then it'll run on a cron job every 30 minutes is how it's default set up, I believe. If not, we can log into those servers individually and run chef client, and that'll actually connect to the master and say, what is my cookbook I should be running, and it'll run it. So notes, the master requires a gig of RAM. It'll fail if you have less than that. Execution order is sequential, so it's a little easier to read when you're actually going through it. And then the actual files are written in a Ruby that's a little bit extended. So it's a little more familiar for some Ruby developers. So SaltStack. SaltStack has a layout similar to Puppet. You don't have necessarily a workstation computer. You just have a master, and then you have children below it. The directives are called states. The directive scripts are called SLS formulas, or salt states. The children nodes are called minions. The metadata, so information about the child server itself, so the IP address, the host name, those are called grains. Notice the salt thing going on there. And then pillars are the association of directives and grains together. So they could have just called them children servers, but they didn't. Nobody likes to do that. Install salt on the master. Pretty straightforward. Install salt while you're logged into the children. Edit the Etsy salt minion file, which tells it, hey, I'm this particular child server, and tell it that the master is, again, this is the actual IP address, or in this case, this is in our host file. Test the minion. We're already logged in on the minions. Salt minion debug. That'll ensure that we can connect to the master. Then, similar to Puppet, we do certificate signing. So on the master, we list out all of the keys. It'll show us all the keys of the children that have connected to it, and then we can do the same -A and accept all the keys. So to actually make the equivalent of a cookbook, we're going to have an SLS file and an HTML file, so we don't have to have a special ending to the template file. And then salt. So same thing, we have double curly braces. This is using Jinga, I believe, is the Python templating library that it uses. So double curly braces, grains, so information about the host, whatever the host is. So in this case, puppy.jpg or kitty.jpg. The actual file, oh, that's ugly. So it's a little bit more verbose. It's in YAML. So we have Nginx. This is a package we wanted installed. Service, we want it running. We want to enable it, and we want to require it. I don't know why you have to define that in there again. The actual HTML file that we want to write out, this is the template file. The source is going to be salt://. That'll refer to a file right next to it. We want it to use the Jinga templating language. We want to, before we do this, require the package Nginx. Salt, prior to version 1.7, did things in its own order like Puppet, but post 1.7, you can tell it to run sequentially. So user, we want to make sure that the user puppy exists. We want to make sure the file exists. Here's the source. Here's the hash. We'll use that hash to see if it's changed or not on disk, and only download it if it's changed. Require, again, Nginx, require the user puppy, require the group puppy. And then the same thing down below is what we have for Kitty. Execution order can be sequential now. It uses YAML and Jinga 2. The actual connection, so Puppet, I don't remember, sorry, on how it actually connects back to the master. Chef uses SSH, I believe, to connect back to the master.
To the master, it's using HTTP.
To actually run the scripts?
Yeah, it does all the transfers over HTTP.
Okay, so that's over HTTPS. SaltStack uses 0MQ, so it has an actual socket connection between all of the nodes. And then one of the, if you consider it downsides, they wrote or they used another library to add encryption on top of 0MQ, because 0MQ is by default everything's in plain text. Remote execution is standard. I'll show you an example in a little bit how you can run commands on all your servers. So Ansible. Ansible layout. In the Ansible layout, it's a little bit different. Everything runs off of SSH. So instead of having a master per se, most of the time it's all push. So what they call that is a workstation. So you don't have a workstation and a master, you just have a workstation. So directive are tasks, directive scripts are playbooks, and children node are hosts. So we're going to install... Okay, that's wrong. Install Ansible on the master. Add their repo, run an update, install Ansible. Tell the master in the Ansible hosts file where its children are. So puppy.dev is under, these are how you do groups. So picture this as web servers or web server group puppy, and then kitty. So those could be IP addresses. In this case, they're host names. We have to make sure that the master SSH or the SSH key of the master of the workstation is on all of the clients. But other than that, we don't have to do anything on all the children nodes because everything runs across SSH. We're going to write a playbook. So so hosts, all, we could say, like we can here, these are the actual groups that you saw in brackets in that host file. Hosts all, make sure we have Nginx installed, make sure we have Nginx running and started. On puppy, we want to make sure that we have the group puppy present. We want to make sure the group or the user puppy exists. We want to make sure puppy.jpg exists, and ensure that the index.html file gets written. And the action here, that's where we define use this template. Here's the source and the destination. So in this case, name is actually just what shows up. That has no real ramifications. That's just when you view the output, you know what it was running and whether it failed or passed. Execution order is sequential. Like SaltStack, it uses YAML and Jinga 2. All remote execution runs across SSH. For the remote execution, here's how you run it on Salt. Salt star meaning run it on everything. Command.run is the module you're going to run. Run date, and it runs date on all the servers and returns it to you. So say you have 40 servers, you want to run out, see what the time is on all of them. It'll run that, give you back the commands, or you can check whatever you want to check. Ansible, same thing. Ansible all is the group name, so we could do Ansible puppy, Ansible kitty. -m command is the module, M for module, and A is the actual action we're going to run, date, and then it responds back what the dates are in each of them. Okay, questions? No. Is that because I went too fast or because I'm an amazing presenter?
I have a couple questions. On all these, I'm assuming this is used for more than just installing Nginx.
Yes. I will show you what we're using it for, and then we'll actually go through on Ansible how we'll do an example of Vagrant, and then we'll do an example running on DigitalOcean also.
Yeah, I mean, definitely the one thing to keep in mind is, at least in the chef case, you wouldn't actually write it the way he did it.
Okay, yeah, those were very basic.
Because, so, like,
instead of like putting ifs in your code, you would do roles and then assign run lists to those roles and then assign roles to your nodes. You know, you can do that if you're managing web servers and database servers. But if you have 10 different types of servers, then that system makes sense. And then Chef also, just to be a pain, also has a mode where you can run it without a master server called Chef Solo, which a lot of people use when they're just using it for Vagrant on a local machine.
Okay.
But the annoying thing is server APIs have a bunch of stuff for searching data bags, which is the metadata stored about stuff, and they don't all work the same when you don't have a server, just to cause compatibility issues.
Interesting. So I'll go through a Ansible example, and if you want to pipe in at all on how that works with Chef, that would be cool. So in this case, as I showed you before, we have that host file where we had kitty and puppy. So in this case, we have Vagrant, and we have the IP address we're going to use for our Vagrant file. And then we're also going to do it for DigitalOcean. So in this case, we have staging. We could have web servers, database servers, et cetera, et cetera. And then we'll have our actual YAML file, which is our playbook that we're actually, how we're telling it which servers to install what on. So in this case, we're saying, hey, on all the servers, these are some variables we're going to pass in. We're going to say, hey, include the comment role, include the deployment role, and then just on the host Vagrant, which in our case are still all of them, install the role or run the role db, httpd, php, and service at name here. And like he was saying about roles, we'll have a couple different roles here. And this is where you can start to segment down and you can say, hey, on all of my servers I want to run this. On just my app servers I want to run this. On my web servers I want to run Nginx. So in our case, common. It's broken down into 4 different subgroups. So we'll have a roles folder, which tie to these roles right here. Inside there we have files, which is where we save all of the files we're going to copy over directly. Templates, where we use our templating language. Tasks is what we're actually running, that the playbook, the actual commands we're going to run. And then handlers are, think helper functions. So we can write a handler for restarting Nginx, and then we can just say, hey, restart Nginx when I finish this command. So in common, so this one's a little bit confusing. So we'll go to this one first. We'll go to database. So in this case, Yum package, so this is running on Cent. The other examples were on Ubuntu. Yum is the module, so module colon, and then it has a cool feature where you can actually run loops. I assume you can do the same thing in Chef for lots of Yum stuff or lots of apps, app-get stuff. Install MySQL Server, install MySQL Python, and then make sure that it's present. You can use removed as well. Then create our configuration file from our template file, and then notify, this is where those tasks come in. So restart MySQL is a task we've defined that, or written that says service MySQL restart. Once we create that, create these databases for us. I was playing with the user, but I got it to work. So we're going to create a dev application user app, password app, and give it all the privileges, because why not? For local host and remote host. And then we're going to insert an IP table rule. So line in file, again, is another actual module, and this will check to make sure that that line exists. If not, it will insert that line and then restart IP tables. So we'll look at our PHP one. So we're using a repo called Webtatic, and this will go through and install PHP. If you look at, I'll show this first. Do we have, okay, never mind. So RPM key, again, another module, make sure we have this RPM key installed. We can run commands, so actual command line commands. Install that RPM. Ignore errors true will allow it to keep going. I use that for Composer also. Copy over the key from the repo, and then install all the PHP items that we want. We have a php.ini file that we want to use, so we can copy that over. And again, when we run the copy command and the source is php.ini, the first place it's going to look is inside files. And the next place it's going to look is just in the default, like, root folder. Check to make sure Composer installs. This was a little funky. I got this from a Stack Overflow post. It'll actually just test to see if that file exists. If it fails, you can register a variable and then use that variable again. So in this case, we're seeing if it exists. If it doesn't, we're installing it and then moving it over.
One quick question.
Yes.
So you've got yum here, copy. Are you defining those, or are those keywords already defined and associated with the yum command?
Those are modules that come with Ansible.
Okay.
So you can write your own module in Python. Otherwise, they have a whole bunch of modules.
But all the basic stuff.
Yes. They're also, apparently, I haven't tried it, but according to them, they're very helpful with if you write a module, they'll help you write it correctly and then add it to their repo so that everybody has it. Probably to get people to use it and not any of the other ones.
Sure.
So
shell is obviously escaping the shell.
yes. So you can do, if you want to run ensure statements, like dependencies basically for the roles, you can do that. So in this one, let me close all these. So our service app name. So what we can do here is inside Meta, this is another folder we can, it'll look in. These are dependencies. So we can have a dependency, make sure we have deployment. In our case, we were using deployment to actually deploy our deploy key. Ensure that PHP is installed and ensure that Apache is installed before you do any of this. And it'll make sure those roles run before these do, even if you didn't define them in your original playbook. So tasks. Let me see if I can. So this is installing. It was copied from a Laravel app, but verify the existence of these folders. That's where we're setting all of our config files. Deploy our MySQL config. So we have those in different folders depending on, yes?
What happens if it is trying to verify the existence of something not there? Is it created?
Yes. In this case, the state directory. So this is the file module. Make sure that these are directories.
Right, and if not, what happens?
It will create.
It will.
For this module, yes. So the yeah, most of them have a state of present. The yum repo or the yum module does it that way. In this case, the state is directory. So make sure that this is a directory, or make sure create if it isn't. Then copy over our actual MySQL configs for our. This is for our PHP app into those folders. It gets cut off there, but secure is where we store our local. So it's only checked out on our workstation server we have for production. There's a folder called secure where we have our production keys. HTTPD, make sure we have our vhost file copied over. Our vhost, our httpd.conf file checks inside auth-fold conf httpd and includes everything.conf. We're going to deploy our vendor configs. So vendor 1 and vendor 2, make sure those are copied over, and our app was looking for those. Deploy the actual app using Git. Here's something kind of cool that I liked. If you look at the very end here, oh, this is wrong, but if you see here, version equals that, this is in the get module. So what it's going to do, we have a variables file, and we actually have, so let's show that one. So that variable is getting referenced here. So right now it's set to master. But you can actually put a checksum of your get check-in and revert back and forth between if you need to revert back, similar to how you do with Capistrano or however you're doing deploys now. In this case, we're just deploying master. So you change that in the config file, and then when you rerun the playbook on whatever servers that app is deployed on, it will revert everything back to that. So this is Laravel crap, if you will. Set ACLs on your storage repos when it's first done. There's a Composer module, which will actually install your Composer modules from your composer.json. And then at the bottom, we're restarting Apache. So I'll test this. Well, one other thing I'll touch on is this group vars folder, similar to this roles folder. It will automatically assume these variables. If you name something web servers, it will automatically look in here, and if you have a web servers file, it will include that for variables. So if you name it, I don't know, PHP web app number 2, it'll automatically look in here and look for that variable file, so you can have without having to actually define them. So we can actually run this. So Vagrant, to have Vagrant run this, so the only real thing you have to look at is we're specifying a specific IP address over here, 172.16.0.11. And then for the setup, if you're doing bootstrap.sh, you may have in there bootstrap and then the bootstrap file. In this case, we're using Ansible. So the dependencies to run this, you just have to have Ansible installed in your system. If you're using Mac, you can use Homebrew to install it. The top one just has to be there. You're telling it which playbook to run, and then the host file to run it on. And that was just the IP address of the actual Vagrant box. And then when you Vagrant up, at the same time, I'll test this on CD7. Right. So I have gone into DigitalOcean. All I've done is deploy this box AZPHP. When I deployed it, I told it to put my SSH key on the box, and that's all I've done. And we'll test this and see if this works. Yes. So I'll put this one over here. So this is our Vagrant box right here. It's going through each of those tasks in the playbook, copying over the DNS files, copying over repo definitions, then installing development tools, and that one usually takes a minute. So this one's running on DigitalOcean. So it basically takes all of those scripts that you want to run, all of the definitions and everything, copies them into a big blob, connects over SSH, and then runs everything remotely on that server. And while these...
And you don't have to install anything on that server.
No, that was one of the things that we looked at. I have a friend that's using Salt, which has very similar benefits to what Ansible has. The problem that he had was in the past year, Salt has gone through a lot of upgrades, and he would end up where his Salt node servers or children servers would get out of date of the master server,
right,
and then you couldn't connect anymore. It was using different definitions. It happened once, I think, but it was a pretty traumatic experience, apparently. So one of the things that I did like is with Ansible, literally you have no template file you have to run anymore. If you're trying to do this at scale in production, you might want a base template image that you work with, but you don't have to. So in this case, again, the DigitalOcean box, we haven't done anything. Just a straight box up from...
SSH key on it.
Yeah, and if DigitalOcean, in this case, you can do the same thing with, so here's the example we had with EC2, where we actually run stuff. So you can tell it, hey, here's the box IP address, here's the SSH user I want you to use, and here's the private key file I want you to use for Ansible to connect. And this is where all those, the name colon and whatever you were writing, this is the role that it's running, and here's that name that you wrote in. In the case that we did loops, here are the loops that it's running through. So yeah, I was pretty excited when I first started figuring this stuff out. This is, again, a very novice opinion of this. I've been running with Ansible for about 3 weeks now, so this is just what I've learned in that time. Some of the problems that I've run into with config management, I'll let you speak to if you've run into some of these problems. At scale, if you start spinning up a lot of boxes, the config management side runs really well. The problem that you start to have is the third-party dependencies, just like you have with Composer, where if this Yum repo happens to be down for a second or it can't connect or there was a HTTP problem, because you're running these installs all the time because they're so easy to run now, you start to get failures on those third-party installs, and then you end up with servers that are out of state because these all just fail and then say, oh, well, I didn't finish, I'm dead. So what?
I like that.
So this is the. So this is it turns red, but this is the check to see if Composer exists. So it tests it and then it ignores it, but it registers that variable. I was trying to see if you can make a different color because it is terrifying when you have it on the side screen. You're like, oh crap.
Yeah, so the one thing that I have done is I wrote a small Nginx setup that gives me a proxy to GitHub, and then I do all my deploys from the tarballs on GitHub, so that I don't have to figure out how to clone Git in a reasonable way. And doing HTTP caching with Nginx is like an hour worth of work. So that's given me a lot of been a nice setup. And then currently what I'm doing to not run the problems with Composer is checking the Composer stuff into the repo so it's all in one tarball.
Do you check the entire vendor?
Yep.
Okay, I tried that and ended up with really deep get ignores and stuff that flipped out. Or do you have to?
You should be able to.
I haven't had a problem, but the one thing that really helps is you set your Composer state to prefer dist installs,
Okay.
which does a tarball install, so there's no baggage or anything.
Okay, so maybe I didn't have that set.
And then also just an ignore rule, rule to ignore any git ignores in your vendor.
Okay.
I don't know if that's the best, but at least in my current deployment scheme, that works really well. I think long-term what I'm going to be switching to is writing my own kind of deployment setup that will run Composer on my server and build tarballs so I don't have to check it in. But definitely if, I'm running 50 servers right now and I don't even want to rely on GitHub being slow. It's just too painful.
Or down, yeah.
And so having that caching layer is huge. The other thing that I do that makes me hate my choice of choosing Chef is I run it in kind of a non-Chef-like way. I run it all push, which Chef does support. And so I'm always kicking off my runs using SSH. And I hate the way that Chef manages everything in this. All your data ends up in a database in Chef on your master server. And it's kind of very opaque and annoying. And so it's not how I want to manage things. So I actually have a config file that manages everything and then scripts that update the databases. I wouldn't choose Chef again, even though it's very flexible. My big reason for choosing it initially was that there's a lot of support built into Amazon services for Chef. It's just in my cases, I wasn't able to use any of that support to match the workflows that we were trying to do. So the big use case for Chef didn't pay off for me, so now I get kind of the things that weren't quite the mix for one that I do with none of the games. So maybe something like Ansible here, which doesn't have a master server and is very config file based, matches the workflow I want better. Though, maybe long term, the Chef approach with the database there will actually be better for me.
The one interesting thing I did see, because we're running our production, or will be running our production at Amazon, is instead of having these actual, so just so you see at the bottom, you get a recap of the whole thing, and it'll say these are the 40 things that it ran that had to change, and there was 56 of them were okay. In this case, on this Vagrant one, I had run it, and some of the stuff had changed, so the okays are stuff that the state stayed the same, so rerunning it didn't matter, but it verified the state was correct. So in this case, 64 of them were okay, and 34 of them needed to be changed. So this host file, where you have staging, in AWS, there's a plugin, and it'll tie everything to your EC2. account, or your VP, whatever you want to call it. It'll query all your EC2 hosts. And depending on the tags, you can use tags in AWS as groups. So you can say, hey, create this server and tag it as a database server or web server, app server, whatever. And Ansible will look at those and say, oh, there's a new app server, and you can run directly through that. So you won't end up with an actual host file. I'll show you. So in this case, this is the one that we're working with right now. This hasn't been totally deployed, but this is what we're playing with. So in this case, we have all of our infrastructure services, so monitoring, security, our Logstash servers, our admin kind of portal interface, all deployed on here. One of the cool things that I did like is, so inside here are roles that we have. So we have all of our services actually running as roles. So each of these services just says, hey, deploy this with these configs. And then we have one variable, or one variables file, and that's where you saw the part that I deleted to make it not confusing. All of these have variables, and they're deploying based off of that variable. So now we use this instead of using something like Capistrano to actually deploy code. And we can go in here and like, so the other thing I liked is you can, in our case, we have some common roles in all of our things, so our models and stuff and our business logic that we use on most of our repos or most of our services. We have a role in here that's a dependency, so that it will, we tried using Composer and it failed miserably, especially in development environment with multiple developers, to deploy like our internal business logic code with Composer. So we have it going through like a file system linking base. And this, now each of the services require that if they need them. And then that will deploy all of our core services inside of those.
Are you minifying and uglifying and translating SAS or less? Or like that?
That's a little bit out of my expertise. I know we use, we're using Bower and Gulp for our front-end applications. And I believe those dependencies exist, but we haven't gotten far enough in deploying those yet to actually test it out. But I'm assuming, just like Composer was, there's a Bower plugin, and you can run Bower production, and it'll compile all your assets for you.
Yeah, I mean, even if there's not writing your own plugins in any of these things, isn't that painful?
So you could really,
And this is in Python, so.
yeah, you could really replace it with just a few plugins on that.
So, I mean, it really depends on your model. So I'm that way right now. Everything's deployed through Chef. I actually like drive it off my own custom config file that even is like I configure all my Amazon settings. Then I have code that runs that, sets up my Amazon servers. If this is a VPS client that needs 10 IPs, it figures the 10 IPs for all the security groups, and then it runs the bootstrap right after that with the correct services, and up with a server just from the config file, which is great all in one step. But you do kind of like you do some flexibility there too, like you know, I want to deploy, say, new SSL certs from a user interface from the user, but I'm going to deploy my SSL certs through this service. You know, kicking that all back around to go through this might not be realistic. So maybe it makes sense in some cases to use a separate deployment stack. Maybe this code then just calls that deployment stack to do the deploy instead. But for the standard, I'm deploying a single app. You know, maybe it has a lot of servers, but it's a single development group, a regular deployment cycle. I think it's very reasonable to use a tool like Ansible for everything.
Yeah, and like he said, I would go that route too. Why reinvent the wheel? If Gulp does what you need it to do, have this run Gulp for you, so you never SSH into the server and run Gulp install. Now you're just having this do it when it builds the server. Just like we're still using Composer for all of our third-party dependencies for PHP, but we have this call Composer install. Right now, just our Composer lock is in vendor, but if that preferred dist works, our entire vendor repo will quickly be in our Git repo, so we won't be running Composer install except in development. Yeah.
Yeah, I mean, really the biggest thing to think of is that you really move to a model of this base image. Most of the time, you don't even have to create one. For Amazon, I just use the base Ubuntu images. And then you're just building off that. So really, you just have to think about what are my third-party dependencies, and is it okay to rely on them? Like in the case of all your app repos, perfectly fine to rely on them because Amazon has mirrors in your availability zone. So if you can't get to those mirrors, you can't get to your server, so perfectly fine. But for those random composer stuff or GitHub, well, they do go down, so you want to think about how you got to manage that. A lot of people, you know, they might mirror stuff to S3, or like I did, just do a quick Nginx proxy that runs in that same availability zone that covers a lot of those things. It's just some things are a lot harder to mirror. If they don't speak HTTP, it's all of a sudden a lot harder.
Questions? Has anybody else tried config management? No?
I'm just developing this thing called the workflow. Even today I learned about merging. Okay.
It really is worthwhile to use tools like Vagrant for your development, or if you like developing on remote servers like I do, you know, use DigitalOcean, and you can just spin up these servers cheaply and then keep setting them up the way you need to. It really does change the way you think about doing development.
I would, if you're learning how to install Nginx or whatever you're doing, I would say learn it this way. Instead of necessarily logging into a box and playing with it, just start writing scripts, and it now becomes, I mean, I remember not too many years ago running all of our development off of like our actual OS X laptop with Homebrew and Mac ports and all that stuff, and you would get everything configured like production was, and then you're like, hey, I want to test out using Nginx, and so you spend a day removing all of the Apache dependencies you have, and you get Nginx installed, and you finally get the Nginx page, and the next day you have a bug, and you're like, fuck, now I got to delete all of the Nginx stuff you've done, reinstall Apache, get it back the way it was, and this just makes it where it makes experimenting a lot easier, where you can just, I mean, now our entire process of, oh, I want to try Nginx, all you have to do is go in here, change this Vagrant file to, instead of HTTPD, to Nginx, have a role for it, Vagrant destroy, Vagrant up. And now you've got the same server, same app, same everything else, but you're running Nginx instead of running Apache. So now switching back and forth, trying out new things. I want to try Redis, I want to try Memcache, I want to try all these different things. Now becomes not a headache where once you had that pretty little development box running before, it was terrifying to think about trying to install something else, at least in my case.
The one thing you have to be really careful about, though, is making this scripting idempotent once you start going to production. Because in production, you're unlikely to just destroy your production boxes and restart them all the time. You know, you'll have huge amounts of data that you'll have to copy to do that and things like that. So, you know, which is less of an issue if you're running on EC2, because you can, you know, detach and reattach images, but you still probably don't want downtime because you want to change your Nginx config. So making sure you can run things multiple times and upgrade is important.
So don't rely on command and install something. Try to find a module or something where it'll check to see if it's installed and then try to install it. So you're not just overwriting over the top of everything.
Or you have to write those. Like the one thing you had in there, like for installing Composer, probably the right way to do it in Ansible is to write your own module to install Composer. Like, at least in Chef, it looks like it's a little easier to do tons of stuff in Shell, which is either good or bad. But even in that, I found that most of the time you end up wanting to write a provider and spending way too much time in Ruby for my case. But
one of the other things I did like about Ansible over some of the other ones is their actual documentation's pretty good. There are some gaps missing, but it's all pretty centralized. When I was playing with Puppet and Chef, you ended up going to a lot of third-party resources and stuff to try to figure out what they were trying to tell you to do. Or, again, in my case.
Yeah, the Chef manual is covers everything, but it does not include always good examples. And so, like, if you're not, like, a full-time Ruby dev who's used to a lot of the idioms there, Chef is very Ruby-ish, and so when you're jumping in there, there'll be a lot of stuff you go like, yeah, this documentation isn't actually helpful. I got to go find an article or jump in and read the code, but before I can read the code, I got to open the Ruby manual to, what's this?
This is also free, as many services you deploy it on, as long as you don't want a GUI. If you want a GUI, it's about half the price of deploying Puppet production. They have something called Ansible Tower, which is free up to 10 servers. That's what that little ad is down there. And it gives you basically all of the stuff that I was, like actually deploying things and writing your host file, and these are in these groups. You do it all in a web GUI, and you can do stuff if you want that.
So I guess that is one benefit of Chef, is they do have a full open source GUI that you can run instead of using their overpriced hosted service. All these hosted services are way overpriced if you're going to be at scale. Because one of the things you'll notice, like if you start using DigitalOcean or Amazon, is you'll start to run a lot more servers than the big servers. And so all these services where you pay per server, like if it's, and you run into all these services, from like monitoring services like New Relic or CopperEgg to UIs like this. You're like, well, I'm going to run 30 servers, and these servers, like if you're using DigitalOcean, only cost me $40 a month each. These management services are costing me $60 a month per server. It really starts flipping over in a very ugly way the economics of cloud hosting. And so I definitely stayed towards things where you're using those open source tools. It's really kind of a painful reality that does not mesh up well with how cheap cloud servers are getting.
And if you think this is crazy, so I went from before this, like the config management that we did was with Vagrant was a bootstrap.sh file, which was literally every command I ran on the server, I copy and pasted into this bootstrap.sh file, and that's how we built our Vagrant boxes, and we thought it was the coolest thing ever. That was like 5 months ago. So I've come from that, and then talking to some people, I didn't realize how far behind I was actually was. Apparently, some of the larger people that are using auto-scaling at Amazon and stuff, because of some of the third-party dependency issues that they have, they were getting something like about 5% of the time, one of the many third-party packages they were installing would fail, and then the entire server would fail. So they have, I have a buddy that works at Fender, and they have tied into Jenkins, so they're continuous integration. They run their unit tests, everything passes. It then runs the config, creates an AMI, so a template at Amazon, runs the config management on the template, then compiles it back, creates a new AMI, and spins out new services or new servers at Amazon and deletes all the old servers. So what I keep getting told, I don't know if I'm quite there yet. I don't know if I can quite handle the red pill or the blue pill, whichever one it is. Every code deploy they do, they delete all the old servers and spin up new servers.
Wow.
Which I can't really get to yet. It's still more of a like updating code, but once you have it all automated, you can get to that point, which is kind of crazy. Netflix actually has an open source tool that will re-AMI your AMIs from your CI server.
Yeah, I mean, the problem with that is it's like the least efficient way, money-wise, to use Amazon. You always pay by the hour. So every time you start a server, you hit another fee. Which, you know, on these big guys with these big budgets, they might not care about losing an extra 5% or whatever.
Yeah.
But
one other thing I didn't touch that I don't think you can do with, well, I'm pretty sure you can't do Chef or Puppet. You can kind of do with SaltStack, but Ansible comes built out of the box with, is rolling updates. So if you are deploying code on servers, the serial number is a misnomer. That's how many you want to run in parallel. But you tell it, okay, on all the host web servers, I want you to log into all the Nagios boxes and turn the alerts off to this box, log into all of your HA proxy servers, or in our case, it'll actually connect to your Elastic Load Balancer at Amazon. Take this server out of that, run these roles. You can write a test and have it curl a particular URL and make sure everything's running. And then after it's run these roles successfully, turn Nagios back on, put it back in the load balancer, and move on to the next server, which I thought was kind of cool.
yeah, I mean, you had do that with Chef, but you'd have to move out of kind of the standard way of doing Chef.
Do you use for your code deploys? Do you actually use Chef and like just deploy this version, or do you use Capistrano or something like that?
Right now, we just use Chef. There's a module for deploying artifacts. We use that. It's kind of like Capistrano Lite.
Okay.
It has, it's like an 8-stage deploy process with hooks you can run at the various steps. It's okay.
All right. Well, that's all I have.
Cool. Thank you.
I would definitely say having used Ansible, looking at the config files, it definitely seems better than the older ones, than like Chef or Puppet.
Yeah,
It seems more readable and kind of less. With Chef, you just end up writing a lot of Ruby in your config files to make things work, and it just really hurts the readability. And like if you become a Chef expert, then you hide a lot of that by creating new providers and lightweight resource protocols for everything. But that's just like huge effort anytime you need to do custom. And I don't know how writing a module is in Ansible.
I'm not sure yet.
It's at least its basic config looks nicer than Chef. So.
And it's Python, which I would prefer over Ruby, but
I mean,
if you're writing something.
I don't really like either, but I think I would prefer Python.
If you want to play with stuff, go to Ansible, their GitHub repo, and they have an Ansible -examples, and then they've got a list of all of them. So you can do, I guess this is a Hadoop cluster. Hopefully you don't have to work with JBoss. But LAMP simple does like, I think there's I guess that's it. It has like a load balancer and a database server and a web server, and you can see how their configs run. And you can basically copy this down directly, change your Vagrant file, and just say, hey, run this playbook where I had playbook.yaml or vagrant.yaml. All you have to do is do that, and it'll run fine most of the time. Their errors are also pretty wordy and helpful. But yeah, there's WordPress too if you want to play with WordPress.
Thanks.